Hey everybody, Mrs. Bianchi. On the coordinate grid below, point J, right here, shows the starting location of Jake, and point L, right here, shows the starting location of Lisa. They remind you that each line is representing 2 kilometers. Jake walks from his starting location for the same amount of time as Lisa walks from her starting location, so that's important, and it'll make more sense why in just a second when I map this out. Jake walks east at an average rate of 4 kilometers per hour. Lisa walks west at an average rate of 3 kilometers per hour. Jake stops walking when he reaches the point directly north of point L. So where does that put us? So somewhere in here, he's going to stop. So if I go north from point L, that puts us over here somewhere. So they want to know which ordered pair describes the location of Lisa when she stops walking. Now, I thought what we would do, because I think this particular coordinate plane going by twos is too confusing. So I propose that we look at a more traditional coordinate plane where each line represents 1 unit. So let's first of all think about Jake for a second, because what the directions said, if we go scroll down here and look, it says he walks east. Now, east would be going to the right at an average rate of 4 kilometers per hour. So each line is representing 1 kilometer, right? So first of all, if we go back here, let's make sure we understand what the ordered pairs are. So if we were to figure out what's this ordered pair, we have to go left 8. So Jake's x coordinate is a -8, but his y coordinate, some people would think that this matches up with the 5, and it doesn't. Why? Because each thing is 2. So if this is 2, 4, 6, 8. So it's actually lining up with the 6. So his ordered pair is -8, 6. And Lisa's is a little more obvious because the numbers match up. So it's over 4. The x is a 4. And the y is a -4. So what I've done is I've rewritten those coordinates right here. So here's Jake, -8, 6, and Lisa is a 4, -4. So let's plot those on this coordinate plane. If we go left 8 and up 6, that puts us right here for Jake. And if we plot Lisa, we're going to go over 4, down 4. And let's plot an L. All right, now remember, we want to stop when we get here. We're going to stop when we get here. So I'm just going to put, how about a yellow mark right there? Because we want to be directly north from Lisa. So this is our stopping point. All right, now here's where it gets a little bit tricky. Because it says, again, it says he's walking east. So that means he's going to the right at an average rate of 4 kilometers per hour. Now, if we go back 4 units from here, see this red line is 4 units. See, 1, 2, 3, 4 units. So right there, that's 1 hour. So let me just put a little notch here so we can see that a little more carefully. So right here, at that point, this is 1 hour. So if we clone this, this would be another hour, right? So now we're up to 2 hours. 2 hours. Let's put a little mark. Okay. And then I'll clone this line, which is 4 units long. If I clone this, now we're up to 3 hours. And see, we've reached the spot that we were looking at. So a total of 3 hours. Let's write that down. Now, why is that important? It's because it says that they're using the same amount of time. So that means if Lisa's going to the west, if we look here, Lisa walks west at an average rate of 3 kilometers per hour. That means we have to kind of count out to the west. See, 1, 2, 3. That's 3 kilometers right there. We know that took her. In fact, let me replace that black line with this green line because they're the same length. Right there is 1 hour. So let's make a little notch and put down that's 1 hour. And she went 3 kilometers to the west. So she's going in this direction. She's going this way. So if we clone that and figure out another hour, because remember, we're going for the same amount of time. So we know that we would want to go for 3 hours. So we're going to go another 3 kilometers. So now we're at the 2 hour mark. 2 hours. And we're not quite there yet because we want to make it to 3 hours. We're going to clone this line again. There's another 3 kilometers. And now where have we landed? We landed right here. Now let's mark the 1 hour chunks. So that's 3 kilometers in that first hour. And then we went 1, 2, 3 in that second hour. And then this represents the third hour. That's this line right here. So what is the question actually asking? It says, which ordered pair describes the location of Lisa when she stops walking? She stops walking here because she's walked for 3 hours. They're the same amount of time. So basically what you're finding out, what's the ordered pair of this dot right here that I'm pointing at, and that will be your correct answer. Now it's my hope that you realize how difficult, if we had used this coordinate plane, do you see how much harder that would have been to try to deal with the 3 hour chunks? Putting it on this plane, we were able to see the 3 hour chunks of time of her heading towards the west a little more easily. And we were able to see, directly north just a little bit easier on this coordinate plane. All right, hopefully this video helped you a lot. The wording on this I think is just horrible. And I especially think it's horrible that they're giving you this coordinate plane. But looking at this video should definitely have helped you quite a bit.